All right, and welcome back. In this video, we are going to be going through Chapter 7, Section 6, titled Proportional Lengths. And by the end of this video, we should be able to apply the Triangle Proportionality Theorem and its corollary, as well as apply the Triangle Angle Bisector Theorem. So please have out your guided notes. Let's begin. We're given a diagram over on the right, segment AC with point B alongside, and segment XZ with point Y on the inside of that segment. Well, if the length of AB divided by the length of BC after it's been segmented is equal to the length of XY divided by the length of YZ, then segment AC and XZ are said to be divided proportionally, which leads into the triangle proportionality theorem. If a line parallel to one side of a triangle intersects the other two sides, then it divides those sides proportionally. And what that really means is that the properties of proportions allow the triangle proportionality theorem to justify many different equivalent proportions. And some of these equivalent proportions, along with informal statements describing the proportions, are given below. So we have a diagram over on the right-hand side. We have a big triangle DEF and a smaller triangle DGH. We're able to compose the following. DG over GE is equal to DH over HF, which is the larger piece over the smaller piece, is equal to the larger piece over the smaller piece. Well, as we continue down, GE divided by DE is equal to HF divided by DF. The smaller piece divided by the whole side is then equal to the smaller piece divided by the whole side. DG divided by DE is equal to DH divided by DF. That's the longer piece divided by the whole side is equal to, again, to the longer piece divided by the whole side. We can also say GE over HF is equal to DG over DH, which is equal to DE over DF. Smaller over smaller, larger over larger, whole over whole. And triangle DGH is similar to triangle DEF. So some of those equivalent proportions could have been justified by similarity postulates or theorems. With so many equivalent proportions, most exercises can be done more than one way. In example number 1, we're asked to find the value of x. Well, we're given have a triangle on the outside. Looks like we have a set of parallel lines. We have a parallel lines that is segmenting the sides of that big triangle, and we're asked to find the value of x. Now, there are a lot of different ways to set up these proportions. You could have x over 15, the whole divided by the piece, is equal to the whole 28 divided by the corresponding piece of 20. You could have done 15, which is the small piece, divided by this missing piece right here, 15 take away x, or x take away 15, I apologize. And that's equal to 20 over 8. There's a lot of different ways to go about setting up these proportions, but so long as your proportions are set up correctly, we're going to end up with the same result of x being 21. With this in mind, please work on problems 1 through 6 on the guided notes. Resume when you're ready to move forward. And you know that if three parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. The following corollary to the triangle proportionality theorem deals with parallel lines and proportional segments. If three parallel lines intersect two transversals, then they divide the transversals proportionally. And in example number 2, we are given just that. We're asked to find the value of x. Well, we have three parallel lines. We have two transversals. So using this is going to be able to find the value of x. Again, there are going to be many different ways to go about creating these proportions, but one of them is done here for you. 4 divided by 16, so a small segment on the right divided by a larger segment on the right, is equal to x over 25 minus x, which again is a corresponding smaller side, on the left, and then the larger side, 25 minus x, on the left as well. Well, we can simplify 4 over 16 to get 1 over 4, and as we solve, we get that x is going to be equal to 5. With this in mind, please work on problems 7 through 9 on the guided notes. Again, there's going to be a lot of different proportions that you can set up. So long as our proportions are strong, we are going to be A-OK. And resume when you're ready to move forward. We also now have what's called the Triangle Angle Bisector Theorem. Try saying that 5 times fast. I know I can. And it states that if a ray bisects an angle of a triangle, then it divides the opposite side into segments proportional to the two sides, or the other two sides. So in example number 3, we're asked to find the value of x. And we're given that this ray bisects the angle because we know we have two congruent angles by the arcs. And we're asked to find the value of x. There are a lot of different proportions that can be made. One that's made here is x over 40 minus x. 40 minus x is this missing piece here. I'm going to fill that in for you because we are going to use it in just a moment. This 40 minus x is equal to 27 over 45. That's one way to go about it. Now, you could have interchanged 27 and 40 minus x to have x over 27, which is equal to 40 minus x over 45. And personally, that's the way that I like to do it. But again, it's just the way that I like it. I like to go from the opposite segment across from the angle over the side. So I like to do x over 27, and then that's going to be equal again to the same scenario. Well, the side opposite of the angle, 40 minus x, divided by the side that we are given that's touching, or that's part of the angle. So you have x over 27 is equal to 40 minus x over 45. Regardless of however we set up these proportions, we're going to end up with the same result of 15. I was just showing you the way that I like to do it. I find that it's a little bit more straightforward because we already have that segmented side opposite of the bisected angle. And then I just branch off from there. Again, that's just me. Some students like to do different variation. That's totally fine. You're going to find ones that you enjoy doing, and once you find it, stick to it. With that in mind, please work on problems 10 through 12 on the guided notes. Keep up the great work. Keep making yourself proud. Let us know if you have any questions, and we'll talk to you soon.